So this is what we used. We strapped this to the back of my motorcycle yesterday. It took a tumble at speed, survived. It's encased in lots of foam. So we'll plug this in, and then the SD card is currently in it. And then I'm gonna go. And then this battery was created by Bill.
Yeah, just something that would interface
so we
with
didn't have to tape a laptop to the motorcycle while it was being used.
Okay. Yeah, I'm just running it off USB power, just because. Oh, I should probably turn it on. There's my desktop. Okay, so right now it's ready to go. The switch is low, so it's not logging anything. So you flip the switch high, one LED comes on, the second LED comes on, it's now logging. So then, so what we don't measure out of the 3 axis is this movement right here, but we do measure this and that movement right here. So then you set the switch low, it closes the file. You set switch 1 high, all the LEDs go high, which means the program's now over, and it is written the file.
Yeah,
So,
and then it clears all the buffers and unbounds the file system, so you know you're guaranteed that the data is on the SD card. Even though there's some times where you can pull it out before you put the second switch in 1 up, but there's always a chance that it hasn't unbuffered all the data. So we can. This is our raw. You'll see the raw format. Then we had a spreadsheet that did the integration and all, actually converting it into angles per degree. Just open it with that. Yeah, we also use new lines, so
it doesn't work right in Notepad.
Yeah,
because it doesn't have the backslash
yeah, it doesn't
R.
have
It just has a backslash N.
So you can see this, and this offset at the beginning is you have to calibrate what 0 is off your gyro, so that we just print that out just as useful information, and then you can see this is when you start moving it, and if we actually put this data and plot it in Excel, you could actually see the movement. And again, it wouldn't be perfect because we're dealing with the drift and imperfect integration too. But for the most part, it works pretty well.
And then here's the Excel spreadsheet, which was data taken at home, which we ran the mathematical calculation over. So basically, you can see this is your X data. Right here on the left is your Y data, and then this is where we start calculating. You can see over time.
I think on this one I only did
goes wrong, but this is
only the X data.
Right, but here you can see this is the plot that we used in the graph, which is computed from the spreadsheet. But we're not going to do that now because it's fairly time intensive to set up the integrals and run the computation over everything.
Yeah.
So
Yeah, it takes a while.
yeah, that's our project.
Took a spill.
Yeah, it was pretty. Well, what I did was we were recording and I did a wheelie and I was coming up on a curb, so I just kind of kept wheeling over the curb, and the back of my motorcycle wheel hit it, and the box just went flying off. And then the box was off when we picked it up, so the file was somewhat corrupted towards the end. So.
Yeah, because it ended up, I think.
It stayed on. It just somehow unmounted.
Yeah, we had it
Probably
logging
lost the power for a fraction of a second,
so it cut it off and lost the buffers.
Yeah.
Too bad.
But it's just spiked every which direction.
Yeah.
You couldn't really get anything useful from it. If you would plot it, it would be high point, low point.
Especially because if it's moving back a lot, because of the drift, it just goes. It goes crazy because it.
But you guys got multiple runs in with.
Yeah, we got actually a lot of good data. It's just again because we didn't know until probably all the way pretty much the beginning of this week that you need an accelerometer to have accurate data. So.
Yeah, because you always hear about phones, all the applications, they're they got this gyroscope, you can measure your angle. It's not totally true because they got an accelerometer and a gyroscope in them, and it uses both of them, but you don't, no one really mentions the second part.
You don't know about that.
Yeah. And SmartPhone doesn't even, they when you buy this module, they're this is the cream of the crop, the best you can get, this is all you ever need to, do all your measurement systems. It's not really. It would have been nice if you mentioned it on your website.
Yeah, they say it's the best gyro, which it is a really good gyro. But to do what we want to do, you need an accelerometer too.
Yeah. So any questions? Yeah.
Bit bang?
Okay, so
Okay, so basically bit banging means that you control, like have a general I/O, and you control it using software instead of like how we're using in all the labs that we did, like the SPY module. That's done in hardware.
Yeah.
So yeah, bit banging is doing it in software. And
Gotcha.
There's situations when, say you have a microcontroller and it doesn't have the interface you want, you have to bit bang. But again, since you're doing it in software, it's slower. Since you're writing it, you can introduce errors to it. Interrupts can affect it. So it's something you want to avoid. And it's good for initial testing. Just see like, oh, can we use this
Gotcha.
Device? But if you can't, I would move away from it.
Huh?
You did that on the LCD.
Gotcha.
Yeah.
I just hadn't heard the term before.
Yeah. Any other questions?
A lot of work.
Yeah, I agree with that.
So just spending 3 days not knowing you're gonna stack off.
Yeah.
Professor Harris, would you like me to get any video on their actual setup? I couldn't see it from the distance that we were at. You can only see that they have a Xilinx board up to use.
Not a battery.
Yeah, just pick it up when you do it.
And then basically you just tilt it like this, and this is your accelerometer. That's your SD card. So my apologies.
Okay.